So far, we've dealt with really simple collisions, right? Things that are moving in a straight line, that move north, whatever. Really straight line, really simple. Now we're talking about things that move at an angle, that after the collision or before the collision or both, whatever. But it just takes another kind of element to these equations. So now we solve for momentum in the x direction and the y direction, and then we might combine those to give us a final velocity, right? So we're breaking things down into x and y, just like we solved our kinematics in the x direction or the y direction and our forces in the x direction and the y direction. We're doing the same thing here with momentum. Okay, so let's list the variables that we have. M1 is 0.5, is moving at 2.4 meters per second east. So V1x is 2.4. V1y is 0, right? And then V1x prime, do we know what that is? 1.8 at 30 degrees north of east. So it's not just 1.8, right? What do we need to do to solve for V1x prime and V1y prime? How do we do that? Yeah, we got to break down that triangle. Okay, so we got to get back here to vector addition. I think it said 30 degrees, right? So this would be V1y prime, V1x prime. Make sure your calculator is in degrees, not radians. $1.5 for V1x prime. And what about V1y prime? Do we agree? Yeah? Okay. Very good. So it says, what's the speed and angle of the second puck? So let me change colors here. M2. What does it say our second mass is? 0.3. V2x is... This is at rest, so that means V2x and V2y are both 0. Okay? V2x prime, we don't know, and V2y prime, we don't know. Right? We're going to find the components of that final velocity, that V2 prime. We're going to find components by finding V2x prime and V2y prime, and then we will build a new triangle, give us our velocity and our angle there, which that's moving. Okay? So I'll show you kind of the format that I go to solve these problems. This does not mean anything that you have to solve them this way, but I'm going to go ahead and get rid of the problem. Are we good with that? Can I erase the problem? Okay. I put white paint. But I had you all tricked, didn't I? Okay. This is the format that I use. We're solving for momentum in the x direction. Okay, so I put label in px, and I just draw this little line. That has absolutely no significance for solving this problem. It just keeps me organized. That's it. That means I'm going to solve all my x within that kind of little system. Okay, this line makes no difference in solving the problem. I cannot tell you that enough times. Okay, so I'm solving for momentum in the x direction, so I'm going to take m1, 0.5 times v1x, which is 2.4. Is this an elastic or an inelastic collision? Elastic. We're still using m1 v1 plus m2 v2 equals m1 v1 prime, m2 v2 prime. Same equation, except we're breaking into x variables and y variables. Okay, is that part clear? Okay, good. So M2 is 0.3, and it was at rest, so it's 0. 0.5 V1x prime is 1.56, and we are solving for V2x prime. Okay. We were lucky here that none of our components were going west or south, right? But if they are going west or south, you have to make sure you include that negative in those components. Okay, we were fortunate enough here not to have that problem. So 1.2 minus 0.78, we're going to subtract 0.78 to the other side. Okay, from there, what would we do to solve for v2x prime? Divide by 0.3. Okay, so that means v2x prime equals 1.4 meters per second. Okay, and since that came out positive, what direction can we assume it's going? East, right? So I like to draw that little arrow, kind of show me where we're going here. Okay? No, you don't have to. It's just kind of reminding me so that when I draw it in the final, I need to make sure it go east. But that's not, again, not necessary. Okay, so then if we solved our x component, we're going to do basically the same thing here to solve for y, except I'm going to say momentum in the y direction. Okay, and I'd say 0.5 times v1y, which is 0, plus 0.3, which was at rest, 0, equals 0.5 times 0.9 plus 0.3 times v2y prime. Okay, we agree there? So the negative here, vertical component, tells us it's going what direction? South or in the downward direction. Okay, but is that where our answer stops? No, we want to find the velocity of our final. So we're going to take east 1.4 and south 1.5. We're going to get the total final velocity of that HAP. Again, it doesn't matter here if we go east first or south first. Okay, we'll get complementary angles. Okay, Brent, what'd you have for the velocity here? 2.05 meters per second at 47 degrees what? Perfect. Okay, I know it's been a while since we've done, south of east or east of south or whatever. Okay, we clear on that? Everybody feeling okay there? Okay, good. Two-dimensional collisions, again, is not mathematically difficult, but if you don't stay organized, and if you're not very diligent about the signs of those components, you could be in for a world of hurt, right? Staying organized is really, really important. So look how many variables we have. 5. We have 10 variables to deal with. Okay, that sounds like a lot. Realistically, not that much more difficult than before. A 7-kilogram object that goes through an explosion. Okay, and after the collision or the explosion, right? That's what we would consider the collision. We have two parts that are unequal. Okay, so is this an elastic collision or an inelastic? elastic. They're ending up apart, okay? But we can think of it as kind of a reverse inelastic if we want, okay? Or we can still think of them as two separate parts at the beginning that just happen to be traveling the same velocity. Okay, you can do it either way, all right? Does that make sense? Kind of. We can have a 5 and a 2 at the beginning and a 5 and a 2 at the end. We can have a 7 at the beginning and a 5 and 2 at the end. Either way, okay? And I say 5 and 2 because we know that 1 kilogram or one fragment ends up being 5 kilograms. Okay. So, how would you prefer to do it? Keep it as 7 kilograms at the beginning or have them separate? Separate? Okay, that's fine. So we'll say this 5 kilogram fragment is our M1. Okay? And so before the collision, this 5 kilogram fragment and the 2 kilogram fragment just happen to be hanging out together. Okay? Really close together. And they're traveling the same velocity. So M1 equals 5 and M2 equals 2 kilograms. Okay, we clear with where the 2 came from, hopefully. Okay, 7 minus 2. All right, so we're not going to use that 7 kilogram at all. They're moving 12 meters per second east, so that means V1x and V2x are both what? Both positive 12. Okay, because before the collision, they're moving together as one. After the explosion, then they move out on their own. Okay, we clear with that part? Yeah. Okay, good. So that means V1y and V2y are all 0. Okay, after the collision, the 5 kilogram fragment moves 15 meters per second south. So that means V1x prime is equal to 0, good, and V1 y prime is negative 15, okay, because it is south. What's the velocity and direction of the second fragment? So we're solving for V2x prime and V2y prime. Okay, so I'm going to solve x first. Again, you don't need to organize yourself that way. Okay, that's just how I do it. So 5 times 12 plus 2 times 12 equals 5 times 0 plus 2 times V2x prime. Okay, are we clear with where those numbers came from? Yeah. Traveling together at the beginning, both 12 meters per second. After the explosion or the collision, that's 5 kilogram fragment's not moving in the x direction at all. Okay, and since it came out positive, does that mean this fragment's going to be moving in the east direction or the west? East, right, so I'm just going to draw my little arrow so I know. Again, not necessary, but maybe helpful. Let's go ahead and solve for the y component. Do we agree with 37.5?
Yeah.
All right, Joey, tell me what you got. Perfect. So instead of having v1x prime and v2x prime, you just have vx prime and vy prime. Right? There's only one common velocity at the end. Hold on, I'll write out the variables here. Okay, so m1. We can do this one together. We'll do the next one on your own. If you would rather do this one on your own, go for it. Okay, v1 x is 12. v1y then is 0. So the difference here is that we don't have a v1x prime, a v1y prime, v2x prime, v2y prime. Right? They have a common velocity at the end. So we're still going to have to solve this in the x direction and in the y direction, but we're going to use our inelastic equation rather than our elastic equation. Okay? Which means what happens in our inelastic equation to those masses? They become 1, right? So what do we do in our equation with it? Add those masses together. Okay? So let's solve the x direction here first. Do I have all my numbers in the right spot? Right? North means v2x prime should be 0. M2 is not moving in the x direction, so I'm just going to plug in a 0 there, right? We don't need to bother plugging in 600 times 0. Sorry, I ran out of room. Try again. Caleb, what'd you have for Vy prime? Mm-hmm. 9.6 meters per second. Good. And it's positive, so. Okay, so looking at this problem, one car's driving east, one car's driving north. So do we understand that it should make sense that our wreckage or our mess of cars should go that direction, hopefully? Okay. I hope so. Okay, Keenan, what'd you have for your velocity here, your final velocity? 12 meters per second. At what? Agreed? Okay, very good.